Hello, my name is Yasser Al-Mashad. I work for F5 as a solution architect. In this video, we will go through a quick demo on the multi-cloud networking. But first, let's understand the challenge and the need for multi-cloud networking. Usually, when people want to protect an application using a cloud provider, the traditional way is to publish this application on the provider global network, and the global network obviously need to have connectivity or reachability to the origin application that need to be protected. But what if this application is not exposed to the internet and not reachable from the provider global network? On top of that, what if this application consists of multiple different components that are deployed in different cloud environments, on-prem or public cloud, and these components now need to talk to each other? This is where multi-cloud networking can help. So in this demo, we will have an application that consists of 3 components, one front end and a couple of back ends. We will deploy each component in a different cloud environment, and then we will use the F5 distributed cloud to facilitate the multi-cloud networking. And the way we will do that is we're going to deploy a distributed cloud node in each one of these sites or this cloud environment. And these nodes will establish a IPsec tunnel to the F5 global network. So it will allow the global network to discover these services, and it will allow them to talk to each other as well. So let's start by deploying the node in the first site in the Amazon. So if you want to create a node in the public cloud, you first need to go to the cloud and edge site sections in the distributed cloud console. Then you need to go to the site management, and then go to the AWS VPC site, and you can deploy the site from here. And this wizard will take you through steps that with some information that you need to fill about, for example, where you want to deploy this node, which AWS region, whether you want us to create the VPC or you can use an existing VPC. Basically, we can create all the objects, the VPC, the subnets, routing table, internet gateway for you. And what you need to provide is only the AWS credentials. So this is the one way to how you can deploy a site node. The alternative methods is that you can use automation using Terraform, which I'm going to do in this demo. So in the Terraform, I also have a script which I have populated with all required information. And basically this Terraform script will connect to distributed cloud, and then from there it will deploy the site node inside AWS. So let's trigger that. All right, so let's do apply. And this might take 5 to 10 minutes. So I will pause the video and I will come back once this finish. All right, and now we're back again after it finished deploying. So it's all success. Let's check the GUI, and we can see the site also up and running. If we go to the site list and we refresh, we should be able to see our site up and running. So the whole process took around 10 minutes. The Terraform scripts first deploy my front-end component of the application in Amazon. You can go on Amazon and just refresh this to see the objects. So yes, 2 machines here, my front-end component of my application deployed, and then this is the site node, which essentially acts as a reverse proxy in front of my application in Amazon. And after that, after the site was deployed and all objects created in the Amazon, then it went also and upgraded the operating system and the software of that node. All right, so now since we have this site is up and running, let's try to publish our application on the global network. So for that, we can go to the, let's open the load balancer tab, and then let's create a new load balancer, and I will call it my app, and for the domain, I will give it myapp.xc.f5demo.io. This domain is already delegated for distributed cloud. It's managed by distributed cloud, which means distributed cloud, it will be able to automatically create the records. Let's double check if this record does not exist on the internet. So just say I will use dig to find out. So yes, it's not available. So let's go back, and I have the option also to automatically generate an SSL certificate and associate it with this host name. So I will also choose that, and I will redirect to HTTPS, and now to the origin. So now I need to point to my origin pool. Remember that my application is running inside a private VPC. It's not exposed to the internet, so I don't have a direct reachability to it from here. So when we define the origin pool, let me call it my app pool, and when I define it, I cannot use obviously the public DNS or public IP. I will have to use an IP on a given site. So I will use IP address of an origin server on a given site, and the IP address of my application is 10. Yes, so this is the one, 10.0.20. So I will take this is the IP. It's a private IP inside the VPC, and this application is running behind my site node, which is called Cloud A, that I just deployed in the inside. Apply, communicate to it over HTTP. So we are doing the SSL offloading in this case, where we terminate the SSL on the distributed cloud global network, sending a clear text to the application on port 80, but still it's in a secured way, because this clear text traffic will go through the IPsec tunnel from the global network to the node. Remember, from the global network to the node in Amazon, it's over IPsec tunnel. So once you do that, we just apply. Just apply this pool. All right. And then optionally, we can apply the security. Could be web application firewall, bot protections, API, DDoS. For this demo, I will just apply an existing web application firewall policy. And that's it. So what should happen now, the distributed cloud will create the DNS record, and also it will maybe take a minute or a couple of minutes to generate the SSL certificate. Let's first test the DNS record. This usually happens quickly. So if I just try to execute this command again, now I can see DNS record is created for it. I will just fast forward the video for a couple of minutes, maybe until the SSL certificate is generated. Right, and now we have the certificate ready. So let's try to access the application. And the application is working. Just to review what we have done so far. So basically we have deployed an application on the Cloud A, which is AWS VPC. And then we have deployed a site node in front of it. And that site node established an IPsec tunnel to the global network. And then we have created a load balancer on the global network that published this application to the users on the internet. And we applied also the security. We can take a quick look again back to the site. We go inside this site list. If you go inside the site itself object, you should see lots of information, analytics, and metrics about the site, the software that's installed, the connectivity to the global network. So RE stands for regional edges. These are the POPs inside the global network. So the node in Amazon established IPsec tunnels to the two nearest regional edges, or the POPs, and so much metrics here about these sites that you can also go through for more information and troubleshooting. All right, now next thing is that in our application, this is a microservices based application, so it have a components which also deployed in different places. So let me just log in. So if you have noticed, this application, it have a components which is running right now. This is the front end component. And then there is a couple of components here, this one in orange and that one on the left for the money transfer. These are two back-end components that is not deployed yet. So what we will do next, we will deploy this component in orange, which is friend reference widget. We will deploy this software or this component in another cloud environment, which will be Azure. And then we will repeat the process by deploying a site node in Azure. And then we will connect the front end to this components via the distributed cloud, multi-cloud networking. So we will do the same process. So we'll go back again here. I will go to Azure and I will execute my Terraform also here. And basically we, as we did with the Amazon, we could do the same things here also from the GUI. So we can go to Azure VNet site and we can just simply create the site from here, providing the same information. And then obviously you need to provide also the Azure credentials and select the image type, etc. But we will do all these steps from the Terraform script. So Terraform will create all of these objects for us. I will just press yes and I'll keep it. So the process will also take around 10 minutes. I will pause the video and I will get back once it's ready. Okay, and now I'm back after around 6 minutes and the site in Azure is deployed. So let's check the GUI. We go to the site list and refresh. So this is the Amazon site. We should expect to see the Azure site, which is here in red because it is doing the software update, right? So this might take maybe another few minutes to upgrade the software on the node itself. And once this done, we should be able to have a healthy node. So as of now, you can see this tunnels are down because the node is being updated right now. So what we will do, we will keep this as is, and we will go and we will create the objects that we need for the load balancer in order for, to allow the front end in Amazon to reach to this back end in Azure. And for that, we need to create another origin pool. So we'll go to the load balancer and then we'll go to the origin pool and then we'll create a new origin pool. I will call it app3 and it's import 80 and the origin server is on site. So we'll say IP address on a given site and the IP address. Now this is the interesting part. So if we go back to the slides here, and if you notice the application in Amazon, the front end, it have the same IP address also on for the application of the backend in Azure website. So we have an overlapping IPs here. And this is where the layer 7 based multi-cloud networking can help to resolve this problem. So we will allow these applications to talk to each other, even if they are having overlapping subnets and IP addresses. All right. So let's get back again. And the IP is the same IP. So I'll just put it here. And the site will be the Cloud V that I just deployed it. Hopefully it's up and running by now. In the inside segment. So we'll say apply and save. Okay. Now let me go back to the load balancer. Now there are multiple ways how we can allow these components to talk to each other. We can create another load balancer for that service on that site, and the load balancers can be talking to each other. And but in this case, I will just modify the load balancer, and I will create a route rules. Basically, route is traffic management rules, and basically I will say create a simple route, and if the traffic HTTP methods is anything that go to the prefix of app3, just forward it to the pools on the site V, which I just created right now, and I call it application 3. Apply, save and exit. Now I can go now to my application, and if I refresh, and assuming the site B is up and running, this component should come also up and running now. And yes, indeed, now we can communicate. So now these components, which is the front end deployed in Amazon, is able to communicate with the component which is deployed in Azure. And this is happening over layer 7. That's why, even though they have overlapping IP addresses, this is not an issue. We could facilitate that communications. Now next, we will have a third site which have a third component, and we will repeat the same process. So we will also deploy the third component, and then we will deploy the distributed cloud node in front of it, and we will use this time the layer 3 connectivity between Cloud A, between Azure and between the Cloud A and the Cloud C sites. But for layer 3 connectivity, it requires non-overlapping IP addresses, as you can see in this diagram. So let's start by deploying the site in the third cloud. And I'm going to do it on Azure as well, but in different VPC. It could be different region, and you can do that in any site. It could be another public cloud provider like Google. It can be also on-prem. It can be your data center. It can be any place. So I will go to my third site here, and I will repeat the process. All right. So also I will keep this running. It will take again 5 to 10 minutes. So I'll pause the video and I will come back once the third site is up and running. Right, we're back again after around 7-8 minutes, and it seems deployed successfully as well. So let's go check that in the GUI. So this is the site list. We refresh, and hopefully we should see a Cloud C deployed right now. And yes, indeed. So now we see the client C up and running. Everything is good. Okay, so now let me, inside Cloud C, we have deployed an application, which is the money transfer application on this, on the right. And we have also deployed also the site node, same as the other sites. So now let's to configure the multi-cloud networking to happen over layer 3. And for that, we will have to go to the, so we want to do this between the Cloud A and the Cloud C. Cloud A, which have the front end, and Cloud C, which have the money transfer component. So we will go to the Cloud A. Let me go to the site management and manage Cloud Site A, edit the configuration, and then we will configure the global network. So we'll say connect to global network, create a global network. I will call it my global network. All right. Type is global network. I will keep the default. Continue. Apply. Apply. Save and exit. And now we need to go to the second site, to the site C, which is an Azure site, and we will connect it to the same global network. So manage the configuration, edit, and then the advanced configuration, connect global network, and then we will choose my global network, the same object that I created for site A. Apply, apply, save and exit. And if everything is done properly, we should have a reachability now between the cloud A and the cloud C over that global network. So let me go to the back into the application and try to refresh. And yes, indeed, you can see now the application of the money transfer is showing up here, which means the two sites are able to communicate. And with this, let's summarize what we have done. So basically, we have deployed an application of three components, a front end, a couple of backends in three different sites or three cloud environments. They could be different public cloud environments or on-premises data centers or edges, etc. And we have configured each one of them with the site node deployed that act as a reverse proxy that publish individual services and expose it to be accessed by another services that's deployed in another cloud environments, as well as the option to publish these services publicly over the global network to the world and apply the security policies like WAF, bot and DDoS protections, etc. And with that, this concludes my presentation. Thank you for watching.